Okay, so for you, our listener, who we know is always up for some deep philosophical pondering, today we're going to tackle something you encounter every single day: technology.
But we're going way beyond just, like your smartphone and your laptop and all that.
Exactly. This is about the philosophy of technology. So
Yeah.
all those really big questions about technology and its place in the world, its relationship to us, to knowledge, to ethics, all of that.
And we've got some great excerpts here from the Stanford Encyclopedia of Philosophy on the philosophy of technology, a really solid resource.
Oh yeah, it's comprehensive, authoritative. I mean, if you want to really dig deep into this topic, this is a great place to start.
Absolutely. And that's what we're going to do today. Unpack these philosophical questions, look at the different schools of thought, the debates, the key
Yeah,
thinkers.
we're going to go beyond just thinking about technology as tools and gadgets and really wrestle with some of the deeper implications.
It's going to get metaphysical, it's going to get epistemological, it's going to get
So
ethical.
buckle up, folks.
It's going to be a wild ride.
Okay, so let's start with the basics.
Yeah.
When did philosophers first start thinking about technology? Like, is this a purely modern concern, or does it go further back?
Oh, it goes way back. I mean, you can trace it all the way back to the ancient Greeks.
Really?
Yeah, they were already grappling with some of the fundamental questions about technology and its relationship to nature and human existence.
I guess it makes sense they were inventing all sorts of new stuff back then, so they must have been thinking about what it all meant.
Exactly. And some of the ideas they came up with are surprisingly relevant even today.
Like what?
Well, one of the earliest ideas is that technology imitates nature.
Oh, yeah. That makes sense. Like, birds building nests that are kind of like little houses, or spiders weaving webs that are like textiles.
Right. Those are actually examples that Democritus used.
No kidding?
Yeah. And even earlier, Heraclitus is considered a potential source for this idea that we learn from nature and apply that knowledge to create technology.
Interesting. So it's this idea that nature is like a blueprint for our inventions.
Exactly. And then Aristotle came along and he kind of refined this idea.
What did he say?
Well, he agreed that technology sometimes imitates nature, but he also pointed out that it can do something else. It can complete what nature can't fully realize on its own.
Okay. I'm intrigued. Give me an example.
Well, think about agriculture, right? It's a
Mhm.
technology that guides and enhances natural processes to produce food. It's like we're working with nature to achieve something we couldn't do on our own.
Yeah, that's a good point. We're extending nature's reach in a way.
Exactly. And Aristotle also made this really important distinction between natural things and artifacts, a distinction in their very essence in their being.
Ontological, you mean?
Yeah, exactly. Ontological. So he said natural entities, they have this internal principle of generation and motion, like an acorn transforming into an oak tree.
It's driven from within, right?
Right. It develops on its own, it can self-reproduce, and it serves nature's inherent purposes.
And artifacts like a table or a tool are different in their essence.
Exactly. Artifacts, they owe their existence and their form to external causes to us, to human intentions and the designs we conceive.
They don't just spring up out of the ground on their own.
No, they don't. They lack that capacity for self-reproduction, and if you leave them alone, they'll eventually decompose back into their natural elements.
So like a wooden bed eventually just rotting away and turning back into earth, maybe even sprouting a new tree.
Exactly. Aristotle used that very example. And you know what's really interesting is that this distinction, this fundamental difference between natural things and artifacts, it's proven to be remarkably resilient throughout history.
Really? I mean, it's an ancient idea. You'd think we'd have moved past it by now.
But we haven't, I mean, even in the Middle Ages, you had Avicenna using this distinction to critique alchemy. He said alchemists could never truly create genuine natural substances because they were always relying on external forces.
Interesting.
And even today, you'll find people who insist that there's a fundamental difference between, say, naturally derived vitamin C and synthetic vitamin C.
Like one is somehow more authentic or better.
Right. It all goes back to that ancient ontological divide and this core question about what artificial creations really are. It continues to inform debates in metaphysics.
So this basic idea from the Greeks that there's a fundamental difference between something that grows on its own and something we create is still shaping how we think about things today.
Absolutely. I mean, think about the debates we have today about genetically modified organisms or artificial intelligence. Are those things truly natural, or are they something fundamentally different? And how does that difference matter ethically or in terms of how we interact with them?
It's amazing how these ancient ideas can still be so relevant.
It's a testament to the enduring power of philosophical inquiry.
Okay, so the Greeks were clearly thinking hard about technology. What other insights did they offer?
Well, another key contribution comes from Aristotle, his doctrine of the four causes.
Oh yeah, that's a classic.
It is, and he actually used technical artifacts like houses and statues to explain his theory.
Okay, remind me, what are the four causes again?
So the material cause is the stuff something is made of, like the wood of a table or the bronze of a statue.
Right.
The formal cause is its shape or structure, so the design of the table or the pose of the statue.
Okay, and the efficient cause.
That's the agent that brings it into being. So the
Mhm.
carpenter who builds the table or the sculptor who creates the statue.
Right, and the final cause.
That's the purpose or the intended end of the thing. So the table is meant for eating at stus, and the statue might be meant to commemorate someone or something.
Okay, so those are the four causes, and they're not just some dusty old philosophical concept, right?
No, not at all. They're still surprisingly relevant today, especially when we're talking about the metaphysics of artifacts.
Give me an example.
Well, take the concept of function. It's something we use all the time when we're talking about technology, but it's inherently teleological. It's about purpose. It's about what something is for.
And that goes right back to Aristotle's idea of the final cause.
Exactly. The final cause is the ancestor of our modern concept of function. And another example is the ship of Theseus, that classic philosophical thought experiment.
The one where they gradually replace every single plank of the ship over time. And then the question is it still the same ship?
Exactly. It's a puzzle about identity over time, and many philosophers like David Wiggins see it as highlighting a key characteristic of artifacts, this tension between the continuity of form and the changing matter.
Right, because with a natural organism, the form and the matter kind of evolve together. But with an artifact, we can keep the form the same even as we replace all the material parts.
Exactly. And that gets to the heart of what it means for something to be an artifact.
Okay, so the Greeks laid some serious philosophical groundwork here. But what happened next? Did philosophy of technology just keep developing from there?
Well, not quite. Actually, there was a bit of a lull after the Greeks.
Really? Why is that?
Well, during the Roman Empire in the Middle Ages, there were tons of advancements in practical technology. I mean, think about Roman engineering or the amazing cathedrals and castles they built in the Middle Ages.
Right, those were impressive feats of engineering.
Totally. But the philosophical reflection on technology didn't really keep pace.
So they were great at building stuff, but not so much at thinking about the deeper implications.
I guess you could say that. I mean, we do have some great practical treatises from that period, like Vitruvius's De Architectura or Agricola's De Re Metallica. They give us amazing insights into the nuts and bolts of Roman and medieval technology.
But they're not really diving into the big philosophical question.
No, they're more like instruction manuals, really valuable, but not philosophical.
Okay, but there must have been some philosophical engagement with technology during that time.
Well, there was some intellectual ferment within scholastic philosophy, a kind of growing appreciation for the mechanical arts.
So like the skills of craftsmen and artisans.
Exactly. At first, they were seen as just imitating nature, kind of like we were talking about earlier with the birds and the spiders.
Okay.
But then in the 12th century, alchemy gets introduced to the Latin West, and that kind of shakes things up.
Alchemy. The quest to turn lead into gold.
That's the one. And it led some thinkers to challenge the idea that human art was just a pale imitation of nature.
Because they were trying to do something that nature didn't seem to be doing.
Right. And figures like Roger Bacon argued that human art, even if it was inspired by nature, could actually reproduce and even surpass natural products in its power and efficacy.
So alchemy was actually a boost for the philosophical status of human creativity.
In a way, yes, it elevated human art, including technology, to a new level of philosophical importance.
But that didn't last very long, did it?
No, it didn't. Unfortunately, towards the end of the 13th century, you start to see religious authorities getting suspicious of alchemy, and eventually they formally condemn it.
So alchemy and its philosophical implications get shut down.
Pretty much, yeah. It's a bit of a setback for the philosophy of technology.
But then the Renaissance comes along with this renewed focus on human ingenuity and creativity. So that must have been a good time for philosophy of technology, right?
It was a turning point for sure. Francis Bacon is often seen as the first modern philosopher to really grapple with technology and its implications for society. And his vision in New Atlantis was incredibly optimistic.
So he saw technology as a force for good.
Absolutely. And that view largely held sway throughout the 19th century, even during the early stages of the Industrial Revolution.
Like with someone like Karl Marx.
Exactly. Marx saw technological innovation as the engine of social progress, the driving force that would propel us towards socialism and eventually communism.
So for a long time, technology was seen in a very positive light, philosophically speaking.
Yes, but then things start to shift in the late 19th century.
Why is that?
Well, one key event is the publication of Samuel Butler's satirical novel Erewhon.
Erewhon.
Yeah, it's a fictional society that decides to ban all machines. They're terrified that machines will eventually replace humans.
Oh, wow. That's a pretty potent idea and pretty relevant to some of our anxieties today.
Totally. And Butler's novel really introduces this critical cautionary theme into the philosophical discussion of technology, this fear of machines becoming too powerful and taking over.
It's the beginning of the robot apocalypse scenario.
It is, and that theme has been incredibly influential ever since.
So the late 19th century marks a turning point where we start to see more critical perspectives on technology.
Exactly, and this trend really picks up steam in the 20th century, and a lot of the key thinkers who are developing these critiques, they're coming from the humanities and social sciences.
Like, who are we talking about here?
Well, some of the big names are Heidegger, Jonas Galen, Anders Feinberg, Mumford, Ellul Winter Borgman.
So these are philosophers, sociologists, cultural critics.
Exactly, and what's interesting is that a lot of them didn't have direct experience in engineering or technology development.
So they were looking at technology from the outside.
In a way, yes, they were more concerned with the broader social and cultural impacts of technology rather than the nuts and bolts of how it works.
They were treating technology as a kind of black box.
That's a good way to put it, and their stance was often quite critical. They emphasized the potential negative consequences of technology for human life, for our values, for our relationships, for our very sense of self.
Like Heidegger, for instance, he famously argued that technology is a symptom of a deeper problem with our relationship to being itself.
Exactly. He saw technology as a manifestation of this tendency in modern thought to reduce everything to a kind of standing reserve, a resource to be exploited.
It's a pretty bleak view of technology.
It is, but it's incredibly influential, and it's sparked a ton of debate and discussion.
And then you have other thinkers like Iden and Verbeek who offer more nuanced perspectives.
Right. They take phenomenological and post-phenomenological approaches, which focus on how technology shapes our lived experience and how it mediates our perception of the world.
So they're still critical, but they're also trying to understand how technology is intertwined with our very being in the world.
Exactly. It's a more subtle and complex view of technology.
Okay, so we've got this humanities philosophy of technology, which is largely critical and focused on the big picture impact of technology. But what about the engineers and the technologists themselves? Were they doing any philosophizing about their work?
Well, that's a tricky question. Some scholars argue that there's a distinct engineering philosophy of technology,
Okay.
and they point to figures like Kapp-Engelmeyer de Sauer. But there's some debate about whether these thinkers really constitute a unified philosophical movement.
Because they weren't necessarily engaging with mainstream philosophical discourse.
Right, and their work is often quite practical, focused on the specific challenges of engineering and design.
So it's not always clear if they're doing philosophy in the traditional sense.
Exactly, and some argue that if you look closely, their views actually overlap quite a bit with some of the humanities philosophers like Ellul.
So maybe the differences are more about their overall attitude towards technology rather than their fundamental philosophical analysis.
That's a possibility.
Okay, so we've got these two broad streams, the humanities philosophy and the less clearly defined engineering philosophy. But then there's this other development that's really important, the rise of analytic philosophy of technology,
Right, and that's what we're going to focus on now.
because it takes a very different approach.
It does. It emerges in the mid-20th century, and it really sets itself apart from the humanities philosophy.
How so?
Well, the humanities philosophy was mostly concerned with the impact of technology on society and culture.
Right.
Analytic philosophy of technology is more interested in technology itself. It wants to understand the very practice of designing and creating artifacts.
Okay.
And it doesn't treat technology as this mysterious black box. It wants to open up the box and see how the gears turn, so to speak.
Wants to get into the nitty-gritty.
Exactly. And it sees connections with other areas of philosophy, like philosophy of science, philosophy of action decision theory.
So it's a more systematic and analytical approach.
Exactly. And you could say that analytic philosophy of technology often functions as a kind of philosophy of engineering. It's trying to understand the concepts, the methods, the goals that underpin engineering practice.
Interesting. But it's not limited to just engineering, right?
No, it also tackles broader metaphysical questions about the nature of artifacts, like what does it mean for something to be an artifact? How are artifacts different from natural objects? Things like that.
So it's both very specific and very broad at the same time.
Exactly. It's zooming in on the details of how we create technology, but it's also stepping back to consider the big picture philosophical implications.
And it's interesting that we have these two separate fields now, philosophy of technology and philosophy of engineering.
Right, and that actually highlights a fundamental ambiguity that runs through this whole field.
Do you mean?
Well, the very term technology can mean different things.
Like what?
Well, one way to understand technology is as instrumentality. Yeah, it's about our efforts to control our lives and the environment by using things, by using tools and techniques.
Okay.
But we can also understand technology as productivity.
Productivity.
Yeah, it's about our ability to create new things to achieve our goals.
So it's the difference between using what's already there and making something new.
Exactly. And the emphasis can shift depending on which aspect you're focusing on.
So when you're thinking about instrumentality, it doesn't really matter whether the thing you're using was created by humans or found in nature.
Right. It's just about how you're using it to achieve your goals.
Yeah, when you're thinking about productivity, the act of creation becomes central.
Exactly. And the nature of the artifact itself, the thing you've created, that becomes really important.
And it sounds like those two main philosophical traditions we talked about, they kind of line up with these two different aspects of technology.
They do. In a way, the humanities philosophy has tended to focus on instrumentality, on the broad societal impact of technology.
While analytic philosophy is more interested in productivity, in the actual process of creating artifacts.
Exactly. But the truth is that technology in the real world involves both of these aspects. They're intertwined.
So we need a philosophical framework that can account for both.
Exactly. That's one of the big challenges facing the field. How do we bridge this conceptual divide and develop a more unified understanding of technology?
Because otherwise it's like we're talking past each other.
Right. And that's not very productive, philosophically speaking.
Okay, so let's dive into this analytic philosophy of technology, because it sounds like you're doing some really interesting work. And one of the things they noticed right from the start was a kind of surprising disconnect.
The disconnect.
Yeah, between the philosophy of science and the philosophy of technology.
Oh, right, because you'd think those two fields would be really closely related.
Exactly. I mean, in the real world, science and technology are intertwined. I mean, modern experimental science relies heavily on technology for all sorts of things.
Absolutely. All the sophisticated equipment, the data collection tools, the analytical instruments.
Right. And many scientific phenomena can only be observed and understood through technology.
Yeah, like we need telescopes to see distant galaxies and microscopes to see tiny cells.
And on top of that, the theoretical research that happens in technology, it often blurs the lines with what we consider pure science.
Totally. So you'd think that philosophy of science and philosophy of technology would be having all sorts of conversations and collaborations.
But for a long time, that wasn't really happening.
No, it wasn't. Philosophy of science was mostly focused on the scientific community, their methods, how they generate knowledge, what counts as evidence, things like that.
And the engineers, the people actually creating technology, they were largely ignored.
Pretty much, yeah.
Which is weird, because you could argue that science impacts society primarily through technology.
That's a good point, but even that doesn't capture the full picture, because science has all sorts of direct effects on culture and thought that go beyond its technological applications. Well, think about the impact of Darwin's theory of evolution, or the conceptual challenges posed by quantum mechanics. Those ideas have had a huge impact on how we understand ourselves and the universe.
Right, and that's not directly related to any specific technology.
Exactly. It's about how science changes our worldview, and philosophy of science has only recently started to really engage with these broader social and cultural dimensions.
So while philosophy of science was busy figuring out how science works, philosophy of technology was kind of left behind.
In a way, yes, and now philosophy of technology is playing catch-up. It's finally starting to engage seriously with the community of engineers and the practice of technology development.
It's kind of funny how science emerged from philosophy, right? Like it was this natural offshoot.
Yeah, they've always had this intimate connection.
But technology and engineering, they had a much more distant relationship with philosophy.
Definitely. And Ole Lashley pointed this out. He said that technology has become the dominant way we address questions of human action. While science is the dominant way we address questions of human knowledge, but he was more focused on criticizing the negative impacts of technology rather than really digging into that philosophical relationship.
Okay, so there's this historical baggage that philosophy of technology has to deal with.
Exactly. And analytic philosophy of technology is trying to do that. It's trying to bridge that gap and really understand technology on its own terms.
Okay, so one of the first things they tackled was this question of the relationship between science and technology, because there's this traditional view that technology is just applied science.
Right, but that view started to be challenged in the 1960s.
By who?
Well, Skolimowski was a key figure. He argued that technology is fundamentally different from science.
How so?
Well, he said science is about understanding what is the case about describing the world as we find it.
Aye.
But technology is about what is to be. It's about creating new things, bringing about desired states of affairs.
So it's about changing the world rather than just describing it.
Exactly. And Herbert Simon made a similar point. He said, scientists are concerned with how things are, while engineers are concerned with how things ought to be in order to fulfill some purpose.
Interesting.
And you could argue that the emphasis in philosophy at that time on descriptive statements about the world might have obscured this crucial difference between science and technology.
Because philosophers were so focused on the nature of scientific knowledge that they didn't really pay attention to the kind of knowledge that goes into creating technology.
Right. And Bunge actually tried to defend the applied science view, but he did make some important distinctions.
Okay, what did he say?
Well, he agreed that technology is about action, but he argued that this action is heavily informed by theoretical knowledge, which is what distinguishes it from mere craft or practical skill.
So it's not just about knowing how to do something, it's also about understanding the principles behind it.
Exactly. And he made this distinction between two types of technological theories. There are substantive theories, which are basically direct applications of established scientific knowledge to the specific task at hand.
Okay. And then there are operative theories, which are developed within the context of applied research itself, but they still use the rigorous methods of science.
So they're kind of like mini sciences within engineering.
In a way, yes. And then Jarvie came along, and he raised some important questions about the epistemological status of technological statements.
Epistemological status meaning,
Like, what kind of knowledge do these statements represent? How are they justified? Are they different from scientific knowledge?
right, so he was pushing for a more in-depth analysis of the unique forms of knowledge that are at play in technology.
Exactly, and this led to a renewed interest in this distinction that Gilbert Ryle made between knowing that and knowing how.
So knowing that is propositional knowledge, like knowing that Paris is the capital of France.
Right, and knowing how is procedural knowledge or skill, like knowing how to ride a bike or bake a cake.
And Polanyi's concept of tacit knowledge also became really relevant.
Absolutely. Tacit knowledge is that kind of unarticulated know-how that's embedded in practice, and it's clearly super important in technology. Like, you can't just learn how to be an engineer by reading textbooks. You have to actually do it. You have to get your hands dirty.
Exactly.
Yeah.
But it's also important not to overemphasize tacit knowledge to the point where we underestimate the role of rational methods and codified knowledge in technology.
Right. It's not just about intuition and experience. There's a lot of theoretical knowledge involved, too.
Definitely. And as Thomas Kuhn pointed out, even scientific practice itself relies heavily on tacit knowledge.
Oh, interesting. So it's not like science is all about explicit rules and procedures.
Nope. There's a lot of unspoken knowledge that gets passed down from mentor to student.
Okay, so the relationship between science and technology is much more nuanced than just a simple applied science model.
Absolutely. It's a two-way street with both fields informing and influencing each other.
And now we get to this really central theme in analytic philosophy of technology, the role of design.
Right, because if we accept that technology is fundamentally about bringing about what is to be, about creating new things, then design is the key activity.
It's how we translate our ideas into reality.
Exactly. It's the process of shaping the world according to our desires and intentions.
But that raises a really important question. Whose desires and intentions are we talking about?
Right, because unlike scientists who are often driven by curiosity, engineers are often seen as service providers.
They're hired to solve specific problems or create specific products.
Exactly. They're realizing goals that are defined externally.
So that leads to the idea that technology is a neutral tool.
Yeah, a mere means to an end, and the engineer is just the person who implements those ends.
But that neutrality thesis has been heavily criticized, hasn't it?
It has, because it ignores the fact that engineers themselves have their own desires and motivations. They're not just passive instruments.
Right, and a lot of technological development is driven by the internal dynamics of engineering itself, by the desire to innovate and push the boundaries.
Exactly. So the instrumental view of engineering is a bit of an oversimplification.
Okay, so let's talk about design itself.
Yeah.
How does analytic philosophy of technology approach this concept?
Well, they see it as a process of creating artifacts, and artifacts are things that are intentionally created to serve a particular purpose.
Okay.
And The design process is often presented as this fairly linear sequence of steps. You start with identifying customer needs.
Right. Like, what do people want? What problems are they trying to solve?
Exactly, and then you translate those needs into functional requirements.
So what does the thing actually have to do?
Right, and then you develop design specifications.
Which are the specific details of how the thing will be built.
Exactly, and that leads to a blueprint for manufacturing.
And of course, there's usually a lot of prototyping and testing along the way.
Absolutely, it's an iterative process. You try things out, you see what works, you make adjustments.
And there's also a growing awareness of the importance of considering the entire life cycle of an artifact.
Right, so you have to think about how the thing will be used, how it will be maintained, and eventually how it will be disposed of or recycled.
Okay, so it's not just about building something. It's about thinking about the whole system.
Exactly, but that initial step, identifying customer needs, it's not always as straightforward as it sounds.
How so?
Well, a lot of design projects are actually initiated by engineers themselves.
Really?
Yeah, they identify potential areas for improvement, or they come up with entirely new ideas for things that have never existed before.
So it's not always about responding to some pre-existing demand.
No, it's often about anticipating needs or even creating new needs.
That's interesting.
And engineers are also often tasked with addressing what are called wicked problems.
Wicked problems, what are those?
Well, they're complex situations where the problem itself is ill-defined and the solutions are far from obvious.
Like climate change, for instance.
Exactly.
Right.
That's a classic wicked problem, and this can lead to the phenomenon of the technological fix.
Where we try to solve a problem with technology, even when it's not clear if that's the best approach.
Right, and the example you gave of injecting sulfate aerosols into the atmosphere to combat global warming, that's a perfect example of a technological fix.
Yeah, it's trying to address the symptoms of climate change without really addressing the underlying causes.
Exactly, and this highlights the need for more philosophical attention to the very concept of a problem.
Like, what makes a problem, and when is a technological solution appropriate?
Right, because wicked problems are often social in nature, and they might require social or political solutions rather than purely technological ones.
But engineers are trained to solve problems by building things.
That's right. And that can sometimes lead to a kind of tunnel vision where they see every problem as a nail in need of a hammer.
And the idea of social engineering is itself a bit controversial.
Oh, yeah, definitely, because it raises all sorts of ethical and political questions about who gets to decide what the desired social outcomes are and how we should achieve them.
So design is clearly not just a neutral technical process. It's embedded in all sorts of social and political contexts.
Absolutely, and that's something that analytic philosophy of technology is trying to grapple with.
Okay, so we've talked about the goals of design, but what about the knowledge that goes into it? Is it just applied science?
Well, it's definitely not just applied science, although scientific knowledge is obviously crucial. But a lot of the knowledge that engineers use is actually generated within engineering itself.
Really?
Yeah, there are whole fields of engineering science that are dedicated to understanding the properties of materials, the behavior of systems, things like that.
Interesting.
And Vincenti actually proposed this really helpful categorization of engineering design knowledge.
Okay, what are the categories?
Well, he said there are fundamental design concepts, established criteria and specifications, relevant theoretical tools, quantitative data, practical considerations gleaned from experience, and design instrumentalities, which are the specific techniques and methods used in the design process.
Wow, that's a lot to keep track of.
It is, but what's interesting is that he argued that at least 4 of these categories represent prescriptive knowledge.
Prescriptive meaning.
Like they tell you what you should do rather than just describing what is the case.
Okay, so it's not just about knowing how things work, it's also about knowing how things ought to be designed.
Exactly, and that introduces a normative dimension into design that you don't really see in pure science.
Interesting.
Even something like an operational principle, which is basically the way a device or system works that can take on a prescriptive quality.
How so?
Well, you might start by observing how something works, but then you can use that knowledge to argue that something should be designed or function in a particular way.
So, like, if you discover that a certain type of bridge is really strong, you might then argue that all bridges should be built that way.
Exactly, and the act of designing itself, it's inherently about bringing about a desired future state. So it's always introducing this sense of should or ought.
Where science is more about just describing what is.
Right, and this distinction between the descriptive and the prescriptive, it's a really key philosophical issue when we're talking about technology.
Okay, so design is this really interesting mix of the descriptive and the prescriptive,
Yeah.
but it's also a creative process, right?
Yeah.
It's not just about following rules.
Yeah. Absolutely. And that's where things get even more complicated philosophically speaking, because how do you analyze a creative process like design?
Well, one way to think about it is as a form of decision making.
Right, because you're constantly making choices about what materials to use, what shape to make something, how to assemble the different components.
And those choices are guided by both practical constraints and your desired outcome.
Exactly. So you have to think about things like cost and feasibility, but also things like aesthetics and functionality.
Or maybe you could even draw a parallel to the distinction between the context of discovery and the context of justification in the philosophy of science.
Oh, that's a good point. So the context of discovery is about how scientists come up with new hypotheses, and the context of justification is about how they test and validate those hypotheses.
Right.
And you could say that the creative phase of design is like the context of discovery. You're coming up with new ideas and exploring different possibilities.
And then the rational evaluation of those ideas is like the context of justification.
Exactly. But in design, the rational scrutiny often has to happen right alongside the creative process.
Because you don't have the luxury of just coming up with any crazy idea you want.
Right. You have to think about whether it's actually feasible, whether it can be built within the budget, and so on.
So it's a much more constrained form of creativity.
Definitely. But surprisingly, there hasn't been a ton of philosophical work specifically on the methodology of design.
Really?
Yeah, it's a bit of a gap in the literature, but Simon's concept of bounded rationality is definitely relevant here.
Bounded rationality meaning.
Well, it's the idea that our cognitive capacities are limited. We can't process all the information or consider all the options.
Right, we're not perfectly rational agents.
Exactly. And so we often have to make decisions based on incomplete information and limited resources.
And we have to be okay with good enough solutions.
Exactly. And that's definitely true in design.
Okay, so design is this complex process of decision-making under constraints, but it's also a multi-criteria optimization problem. Well, it's not like you're just trying to optimize for one thing.
Right. You're usually juggling multiple goals.
Like you want something to be functional, but also aesthetically pleasing and affordable and safe and sustainable.
Exactly. And those goals can often conflict with each other.
So you have to make trade-offs.
Exactly. And this is where things get really tricky because how do you decide which goals are more important than others?
Right, and is there even such a thing as an optimal design?
Well, Franson has argued that finding a truly optimal design is often impossible.
Why is that?
Well, he draws a parallel to Arrow's impossibility theorem in social choice theory.
Okay, remind me what that is.
It's this mathematical theorem that shows that it's impossible to design a voting system that satisfies a certain set of fairness criteria.
Okay.
And Franson argues that a similar problem arises in design. You can't always find a solution that perfectly satisfies all the competing criteria.
So you're always going to have to compromise somewhere.
Exactly. And that has implications for the way engineers talk about optimal solutions.
Because they often claim that they're finding the best possible solution.
Right. But that might be a bit of an overstatement.
Okay, so design is this inherently messy and complex process.
It is, and it's also important to remember that in most cases, design is a team effort.
It's not just one lone genius toiling away in their workshop.
No, it usually involves a whole group of people with different areas of expertise.
And that can create its own set of challenges?
Definitely.